This is WeVision, and I'm Dan Hutchison. Nanodefectivity is the hot topic in semiconductors today as the industry pushes ahead towards 14 nanometers. SEMATECH has been a critical resource in this effort, and my guest, Michael Lercel, who's Senior Director of Nanodefectivity at the Metrology Center there, is here to talk about it. Michael, welcome to WeVision.
Thanks, Dan. It's a pleasure to be here.
So, what's so important about nanodefects, and why are we calling them nanodefects?
Well, it's an interesting question because around nanodefects, as you scale to these small dimensions, you start to see some new effects coming into play. That are the adhesion of particles to surfaces, the generation of particles. So there's some new science that we think is occurring as you reach the nanoscale levels.
And we're basically talking about nanometer types of problems.
Yeah, there's no actual particular number, but somewhere below 50 nanometers or 30 nanometers or 20 nanometers is where some of the physics really starts to change.
And a lot of this is also being driven by the fact that as the industry consolidates, right, and we get in these tighter and tighter geometries, there's lots of push on the supply base to have to spend more on R&D, right?
Yeah, exactly right.
But they don't have the funding because they're not growing as fast.
Correct, exactly right. So the R&D intensity, the amount that they need to invest, continues to increase as the complexity scales as we go to these smaller dimensions. So there's that economic component that goes into addition to the technology component that really puts a lot of pressure on the supply chain.
So that's really one of the key roles that SEMATECH will play here then, because the nanodefects to a great degree are pre-competitive, right?
Yeah, I think pre-competitive or non-competitive, it's an area that doesn't really seem like it would be a hot topic. Most people like to work on advanced devices and lithography techniques, but defectivity is really critical to our industry, and this is an opportunity to really advance the state of the art in the industry today.
Right, because don't most of the big semiconductor companies want to keep the same yield ramps when they ramp a new technology?
Keep the same yield ramp or increase the rate of their yield ramp, if nothing else. I think the pressure on them is to get products in the market even faster than before.